group. So print item.groupDict. This is a dictionary, so we can do subtitle, which is our key. Of course, we could print out the whole dictionary for the item too, and see that the edit string is still in there. So here's the dictionary kept for the very last page. And there's our actual page. Okay, so we've seen how we can match individual character patterns with the setup, how we can group matches together using parentheses, and how we can use quantifiers such as asterisk, question mark, or and to describe them.
Hello. Hello.
Patterns. Something I glossed over in the previous example was /W, which stands for any word character. And so to this point, we've been talking about regex as a single pattern which is matched. But you can actually match different patterns called groups at the same time, and then refer to these groups later as you want to. To group patterns together, use parentheses, which is actually pretty natural. So let's rewrite our findAll using groups. So re.findAll, and then we start our pattern string, and we want the first group, so first parentheses, will be the first part of our pattern, so that would be any word character or space any number of times. And the second group will actually just be this edit tag that denotes to us that it's a header. Nice. We see that the Python RE module breaks out the result group by group, and we can actually refer to groups by number as well with the match objects that are returned. But how do we get back a list of match objects? Thus far, we've seen that findAll returns strings and search and match return individual match objects. What do we do if we want a list of match objects? In this case, we use the function findItter. So for item in re.findItter, and then we pass it in this pattern that we're interested in. And then we can print item.groups. And so this is the groups for a specific match item, and we're iterating over all of them. So we see here that the groups method returns a tuple of the group. We can get an individual group using group subnumber, where group sub0 is the whole match, and the other number is the portion of the match we were interested in. In this case, we want group sub1. So we don't want the whole match, we want the first item in the match. So for item in re.findItter, so we'll pass in our white space or word character any number of times is the first group, and edit is the second group. We'll just print out item.group and parameter 1. One more piece to regex groups that I rarely use but is a good idea is labeling or naming groups. In the previous example, I showed you how you can use the position of the group. But giving them a label and looking at the results as a dictionary is actually pretty useful. And for that we use this parentheses, then a question mark, a capital P, and then the name inside of these angle brackets. Where the parentheses starts the group, the question mark, capital P, indicates that this is an extension to basic regexes, and the name in the angle brackets is the dictionary key that we use, and it's wrapped in those angle brackets. So for item in re.findItter, we could use as our pattern our first group, so parentheses. We want to name it, so question mark P, and I'll name this title, so you see that we keep these angle brackets. And then we actually put our pattern, so we want the set operator, which indicates character matching, and we want to do any word, so slash W, any word character, as well as spaces, so we put a space in there any number of times, so we've got an asterisk for that. Then the second group, we want to name this as well, question mark P, and we'll call this edit link, for lack of a better word, and then our pattern here, which we have to escape the square brackets. So we can get the dictionary return for the item using the .group dict. So print item .group dict. This is a dictionary, so we can just do subtitle, which is our key. Of course, we could print out the whole dictionary for the item too, and see that the edit string is still in there. So here's the dictionary kept for the very last match. So print item.group dict. And there's our actual full dictionary. Okay, so we've seen how we can match individual character patterns with the set operator, how we can group matches together using parentheses, and how we can use quantifiers such as asterisk, question mark, or m-n to describe patterns. Something I glossed over in the previous example was /W, which stands for any word character. And so there are a number of shorthands that can be used with regexes for different kinds of characters, including a period for any single character, which is not a new line, a /D for any digit, and /S for any white space character, like spaces and tabs. And there are more, and a full list can be found in the Python documentation for regexes. One more concept to be familiar with is called look ahead and look behind matching. In this case, the pattern being matched to the regex engine is for the text either before or after the text that we're actually trying to isolate. For example, in our headers we want to isolate the text which comes before the edit render. But we actually don't care about the edit text itself. Thus far we've been throwing the edit away. But if we want to use them to match but don't want to capture them, we can put them in a group and use look ahead instead with the question mark equals syntax. So let's see an example of this. For item in re.findItter, we're going to match our two groups. The first group is going to be a named group called title, and we're just copying that from before. But the second group is actually one of these throwaway groups that is look ahead. So we're just looking for edit, but we're actually not matching it. So what this regex says is to match two groups. The first will be named and called title, and we'll have any amount of white space or regular word characters. And the second will be the characters edit, but we don't actually want this item put in our output match objects. And so we can print that item. And you can see that we have three match objects there, their spans, and the actual values that they match. Let's look at some more Wikipedia data. Here's some data on universities in the US which are really interesting. So with open datasets, Buddhist.txt as file, and we'll read this into the variable wiki. And for good measure, let's print this variable output to the stream. We can see that each university follows a fairly similar pattern, with the name followed by an M dash, then the words located in, followed by the city and the state. I'm actually going to use this example to show you the verbose mode of Python regexes. The verbose mode allows you to write multi-line regexes and increases readability. For this mode, we have to explicitly indicate all white space characters, either by appending them with a slash or by using the /s special. However, this means that we can write our regex a bit more like code, and we can even include comments with the pound sign. So a pattern equals, and we'll use this triple quoted string, which means we will multiple lines. So the first group we want to match is the title. And so here I'm going to say I want it to be a named group called title, and I want any number of characters. And so I'll just use dot star. And we'll add a comment, the university title. The next group is going to be a space, the M dash followed by a space, so I'm escaping that in this case, located, space, in, space. So this is just some indicator of the location. And I don't care about this, so I'm not naming this group. The next one we'll make is the named group city, and this is any number of word characters. And so this is the city that the university is in. Then we have some separator, comma, space, that we see is a common pattern. I don't care about these, so I won't name this group. And then we'll name another group the state. And it's just like city, any number of word characters. So the state the city is in. And then we'll end the triple quoted string. So now when we call find enter, we just pass the re.verbose flag as the last parameter. And this makes it much easier to understand large regexes. So we just use this like previous, and we say for item in re.findItter, we pass in the pattern, we pass in our source text, but because it's this multi-line verbose mode, we say re.verbose to let the processor know. And we can get the dictionary returned to us for the item with the .groupDict value. So we print item.groupDict. And so there we see our output is a set of universities, their cities and their states, and all of the groups that we didn't name are just, they're matched, so they're consumed by the processor, but they're thrown away. Here's another example from the New York Times, which covers health tweets on news items. This data came out of the UC Irvine Machine Learning Repository, which is a great source of different kinds of data. So with open datasets, New York Times health.txt is file, and we'll read everything into a variable and take a look at it. So health is file.read, and we'll look at health. That's a lot of data. So here we can see there are tweets, and the fields are separated by pipes. Let's try and get a list of all of the hashtags that are included in this data. Now in Twitter, a hashtag begins with a £, or the hash mark, and continues until some white space is found. So let's create a pattern. We want to include the hash sign first, then any number of alphanumeric characters, and we end when we see some white space. So our pattern is equal to the hash mark, followed by word characters, or digits, and asterisks, any number of those. And then we'll use a look ahead, just looking for any white space. So we'll use /s in this case. We could have used space if we weren't worried about tabs and so forth. Notice that the ending is a look ahead, because we're not actually interested in matching this white space and returning the value. And also notice that I used an asterisk instead of the plus for matching of alphabetical characters or digits, because a plus would require at least one of each. So let's search and display all of the hashtags. So re.findAll, pattern, and health. So we can see that here there are lots of Ebola-related tweets in this particular data set. This lecture has been an overview of regular expressions, and really we've just scratched the surface of what we can do. Now, I actually find regexes really frustrating. They're incredibly powerful, but if you don't use them for a while, you're left grasping for memory of some of the details, especially named groups and look-ahead searches. But there are lots of great examples and reference guides on the web, including the Python documentation for regex. With these in hand, you should be able to write concise and readable code, which performs well too. Having basic regex literacy is a core skill
python.io